Hello everyone. I welcome you all to Vivekanand Education Society's Institute of Technology's own virtual laboratory. This VLab is based on the subject Electronic Devices and Circuits EDC, or also known as Analog Electronics. In this video, we are going to learn how to perform the experiments and understand their concepts through virtual lab. This virtual laboratory was developed during pandemic when students were unable to perform experiments practically in person, which in turn hindered them from gaining the right amount of knowledge. In order to overcome these obstacles, our Electronics and Telecommunication faculty in charge, Ms. Rasika Naik ma'am, with the help of one of our students, Om Bhatia, developed this virtual lab for our students to gain the practical knowledge that we lack. Now, let us start. The experiments developed in the virtual laboratory are all based on the concept of oscillator. The experiments that students will perform are all part of the syllabus. The list of experiments contains a total of 4 experiments that are as follows: RC phase shift oscillator, Colpitt's oscillator, Hartley oscillator, and Weinberg oscillator. Now, let us start with the understanding of one of the experiments. So let me take you through the virtual lab and explain exactly how to perform these experiments. I'll be starting with RC phase shift oscillator, that is the experiment number 1. Now, the navigation bar in the virtual lab is so designed that it should be similar to the write-up the students have to write. So aim, theory, procedure, etc. are relatable. So the aim of the experiment of RC phase shift oscillator is to analyze the output waveform of RC phase shift oscillator, then to verify the theoretical and practical value of frequency of oscillation of RC phase shift oscillator, and to design the RC phase shift oscillator and verify the design. Moving on to the theory part. In the theory section, the theory has been put up from the standard reference books and sites that are genuine. The theory section contains diagrams and explanations that are easy to understand and that give proper knowledge about the whole experiment. Now, once the student has revised the theoretical part, he can move on to the procedure of the experiment. In the procedure section consists of snips and exact steps that the students have to follow to perform the proper steps in the simulator section. Also, if the student faces any difficulty in the simulator section, he can come back to the procedure and check these steps again to get the required output. Now, once the student has revised up to the procedure part, he can go ahead and take a small test in the pre-test part. This test is designed to understand the gained knowledge by the student. By clicking on the start button in the green, student can start the test and take. If the student is satisfied with the test result, he can proceed to the simulator section, and if not, he can go back and re-revise his concepts. Now let us start with the simulator section. In the simulation, we can see that it has been divided into parts. In this particular experiment, we can observe that there is a controls part, and parallel to it, we have the RC phase shift oscillator diagram. In the controls part, we have components used in the circuit with their units and given set of range. Then we have the output graph part where we can observe the plotted graph. Then we have check output part where we'll check the theoretical and practical values. And then lastly, the extra activity part where student can enhance their knowledge by performing the activity. Now, in the controls part, the student can change the range of the said component by just sliding the slider. Now, to understand what range has to be set, the student has to click on the instructions and read those instructions to set the given ranges of the said components. After the range has been set according to the instructions, students can click on the plot option and plot the graph. Once the graph is plotted in the output graph section, students can observe the graph and calculate the theoretical value of output frequency. After the theoretical value of output frequency has been calculated, students can put that theoretical value in the check output part and verify if the theoretical and practical value match together. After the said activity has been done, students can take the extra activity part and perform it. Also, in the extra activity part, some references are given in order for better understanding of the students. If in the check output part, after checking, the student gets an incorrect output, student can clear all these values by just clicking on the clear option in the controls. So the graph and the values are reset, so the student can perform the experiment again. After the simulation part is completed, student can move on to take a small post-test. In the post-test part, a small activity or a task is given to the students with reference for them to enhance their knowledge. After the post-test, student can move on to the references part. In the references part, the standard reference books and websites used for this experiment have been given in order for the student to understand the concepts in more basic manner and also to gain more knowledge. Now we have completed with the experiment, but wait, there is a surprise awaiting for the students. That is the generate PDF. In the generate PDF, there are proper instructions provided for the students to follow. So firstly, the student has to take snips of the graph and observations from the simulator section and then save those images. Now the student has to click on the generate PDF option in green, which will redirect to the Word doc where they'll get the full write-up right from the aim of the experiment to the conclusion. Now in this, student has to copy paste the saved images and paste them in the observation and graph space provided in the doc. After that, student has to write conclusion in his own words of what he has understood from the experiment and what he has to conclude for the experiment. After this, student has to save this doc file as PDF and then the write-up is ready. If the student wishes to submit the soft copy, he can upload it, otherwise he can also take printout of the PDF. Now, the main goal of this virtual lab was to provide students with practical knowledge and also to perform the experiment virtually. These goals are completely achieved as right from the start of the experiment to the simulation and to the end of the experiment. By generating the PDF, we can clearly see that everything has been done virtually as well as in a user-friendly manner. Now, all the other experiments are also in the same given manner. Therefore, before concluding this video, I would like to say certain points. The entire virtual lab has made a point that the theory in the explained in the experiment has been taken from standard books and sites. Therefore, the students need not worry about. Then, the virtual lab developers have used certain technologies to minimize any difficulty and made a very user friendly. The core aim of this virtual lab is to provide students a virtual platform to perform these experiments without any complexity. Also, this will help the students to revise and brush up their concepts, as this virtual lab is always open and these experiments can be performed multiple times. Now, I would like to thank the developers of this virtual lab, Ms. Rasika Naik ma'am and her student Om Bhatia, for this useful creation for our students. Also, the technologies used in this experiment in this virtual lab are Flash Player JavaScript, and the prerequisite is installation of the Flash Player in your web browser. Now finally, I would also like to thank West Institute of Technology for providing us students such amazing platform and resources. Thank you.